Hey students, good morning, good afternoon, whatever time of day it is. Good time of day. How are you doing today? You excited and ready for this problem? So this problem is going to kind of contain a few major points that will be on the test as far as normal distribution is concerned. So let's take a look at this problem. A machine that makes bearings manufactures the bearings with a mean diameter of 3.01 centimeters and a standard deviation of 0.08 centimeters. So let's read through the problems here, kind of strategize between what two diameters make up the middle 68%, between what two diameters make up the middle 95% of diameters. If the diameter is less than 2.86 centimeters, the product is too small and considered defective. What percent of bearings will be too small or defective? A bearing that's over 3.20 centimeters is too big and is also considered defective. What percent of bearings are defective or too big? Or what percent are too big? And what percent of all bearings are going to be defective, too small or too big? That's part E. Part F asks, what percent of bearings will be between 2.98 and 3.0 centimeters? And if you think you can do that, you try this one. What percent of bearings will be between 2.93 and 3.09 centimeters? And then this is going to be Monday, October, what is that? October 3rd or 4th or 5th? It's going to be Monday's lesson, but what diameter, what value of the diameters make up the 25th percentile? And then if you feel good on that, you can try what value of the diameters make up the 80th percentile. And it looks like that's it. So again, do this as a try along. You can pause the video and try each problem. So let's start. Part A, between what two diameters make up the middle 68% of diameters? Pause it if you want to try it. Here I go. Okay, so middle 68, there's a key word here, middle and 68, and if you look at the next problem, there's also a middle 95. I say key word because this is your empirical rule. 68, 95, 99.7. So we know we have a mean of 3.01. That's supposed to be a 3 down there. That didn't make it look any better. So if I add one standard deviation, which was 0.08, I have 3.09 here. And if I subtract a standard deviation, I get, oh man, that's hard to do in my head. What is that, 2.93? Good. So middle 68%, if you recall, that's one standard deviation from the mean in both directions. So in this case, the answer is going to be between what two diameters? It's going to be 2.93 centimeters and 3.09 centimeters. So part B, see if you can try part B. Well, part B, we know 95% of observations or values lie within two standard deviations. So I just have to add another standard deviation here. Oh man, math is so difficult early in the morning. Let's see if we take away 0.08. Looks like we should have, yeah, you got it, 2.85 centimeters. And if we add 0.8 here, we get 3.17 centimeters. So far, so good? Feeling good? Alright, well, try this one here. If the diameter is less than 2.86 centimeters, the product is too small, and it's considered defective. Between what two values, what percent of bearings will be too small? Well, again, we have a mean of 3.0. If you recall, we went out, last problem, we went all the way out to 2.85 on the left after two standard deviations, but now we have 2.86. That's not going to be one of my pretty empirical values, is it? So what do we need to do here? we need to find the probability that x is less than 2.86, and to do this, now we need a z-score. In fact, anytime I do this, I can use a z-score. So 2.86, and again, if you forgot the formula, it's your observation, that's my observation, subtracted by the mean, divided by the standard deviation. Getting all these numbers right? Okay. So I need a calculator for that. And the z-score I get is negative 1.875, which I get around. It's going to round up. So, so again, I'm looking for the value to the left here on my bell curve. And as long as I'm looking for the value from the left, I can actually get this number straight off my table once I have the z-score. So hopefully you have a table in front of you. There's one in the back of the book. There's thousands online. And just to recall what we got to do here, we're looking for z is going to be negative 1.8, so we need the negative side of the table. We're going to line the column up with negative 1.8. Sorry, the row up with that, and then the column we have to get this hundredth digit. So just that's that same 0.8, and we line this up, and we find the value in there, and I got that number is 0.0301. And if you remember those steps that I did in class, this is step 3, finding the area on the table. And the last step is just interpreting the area, and we're good because we're looking for the value on the left. Things get a little more dicey when you're looking for the problems on the right or between two values, but we went through those cases. So that's my answer. There's a 3.01 chance that the bearings will be too small, or 3.01% of bearings will be too small. Okay, so similar to this, a bearing that's over 3.20 centimeters is too big, and it's considered defective. What percent are too big? So try this one. Pause it. Okay, so let's not go red yet. So now we're looking, here was the mean 3.01, and we're looking for now anything greater than 3.20. So this is when things might seem a little more confusing, but it's not that bad. Well, once we sketch this out, we need a z-score. This is step 2. Step 1 is sketch. Step 2 is take the z-score. So 320 minus 3.01 divided by 0.08. I'm going to pause the video and get that number. And I got that z is going to be now positive 2.375, which rounds to 2.38. Now, when I look at so what that means here, again, just to reiterate what a z-score tells us, is that that value 3.20 is 2.38 standard deviations greater than the mean. So issue here is, I'm going to call this x, because this now when I take my z-score, if I go to my table, I line up 2.38 again. I have the 2.3 row, and I'm going to line that up with the 0.08, and I got a value here on my table that reads sorry, where did that go? I had it a minute ago. 0.9913. 0.99913. Now what this means here on the z-table, remember that the area you always get is to the left. So that's this whole area in here. What are we looking for? We're looking for this region here to the right. That corresponds to this. So the whole area makes up 1. So what I have to do here is I have to subtract that 9913 from 1. It looks like I got a 0.0087% chance that the bearings are going to be too big. So part E, see if you can maybe think about this. What percent of bearings are going to be defective, either too small or too big? Well, from our previous result, we got that the ones that are too big are going to be 0.031. And let me just kind of sketch a bell curve. So we're looking for ones that are too small over here, and we're also looking for ones that are too big over here. And we found that was 0.031, and this one we just did was 0.087, 0.0087, excuse me. So we can just add these together. In other words, there's going to be a 3.88 or 3.88% of my bearings under this situation are going to be defective. Sounds like a lot of wasted product to me. Alright, what percent of bearings will be between 2.98 and 3.0 centimeters? So try this one. This is one of those where we have two values of x. We're going to need two z-scores. So if I look at my bell curve here, again, here's the mean, 3.01. I have 2.98, and I have 3.07. And this is one of these cases where I'm looking for the areas in between. I'm looking for this area right here. So what I need two z-scores. Z1 we'll say is 3.07 minus the mean divided by the standard deviation, and I got 6 eighths. It's going to be 0.75. And Z2 now is going to be 2.98, my second observed value, and that weird thing there was a decimal place, believe it or not. Yeah, my handwriting's bad enough, but on a stylus it's even worse. And on an iPad I can't like put my hand on the iPad when I write, or else things get messed up, so it makes my handwriting even worse than it already is. Alright, I got this Z value here is negative 0.38. Hopefully you did too. Okay, so this is one of these cases where I'm looking for the probability here that x is between 2.98 and those funny looking things are inequalities, and 3.07. So from our rule, that's going to be the probability that it's less than 3.07 minus the probability that it's less than 2.98. And okay, so the probability that it's less than 3.07, I have my z-score from over here. And all I have to do is just find this value on my table. 0.075, I got 0.7734. And again, what that is it's the whole area now to the left of 3.07. So we're taking that whole area, and now we're subtract it from the probability that x is less than 2.98, which would be this area. And that had a negative z-score, a z-score of negative 3.8, so I need the back side of my table. Negative 0.38 is 0.3520. And now I just have to subtract these two numbers together to find the area between the two values. So minus 0.3520, and I got an answer total of 0.4214. Okay, if that one was challenging for you, look at my work here and try this problem. I'm not going to go through it, I'm just going to give you the answer. I want you to pause it right now, and I'll be putting the answer up on the screen in just a moment. Okay, so did you try this problem? And as I'm doing this problem, I pause the video. Oh, Kitty, what are you doing? Don't jump on my computer, black cat. Gee. Relax. Sorry, my cat's getting in the way. He's getting a little feisty. Did you notice the mistake that I made? The mistake that I made all the way back here on problem A. My subtraction wasn't really that good. That should have been 2.83. not that number. This is, no, that's fine, 2.93. I'm fine. I'm okay. That number was fine. I didn't make a mistake. But what you noticed here, if you did this problem, was Z1 was 1 and Z2 was negative 1. So if you recognize this, you could have said, empirical rule. 68% of my values are between plus and minus 1 standard deviation. But if you were actually to do this using the z-scores, you would have found that the probability that z is less than 1 is, where did that go? Is 0.8413. That, again, that funny looking thing, believe it or not, was a decimal point. Looks a little better. And then minus the probability that it was negative 1, 0.1587. You would have actually subtracted these. I got 0.682, what is that, 27 or 26, 27, 24, I don't know. It's early in the morning. What is that? 2.13 minus 0.587, yeah, 0.26. So how does that correspond to our empirical rule? Well, yeah, it's 68.26%, isn't it? So the empirical rule, long story short, it's a little rounded, you know, if you want to get technical, 68.26% of observations lie within plus and minus 1 standard deviation. Okay, these last two problems, as of the time I recorded this video, we haven't covered this in class. I'm recording this video Saturday morning. We're going to talk about this on Monday. But it asks what value of the diameters make up the 25th percentile. So here's how we solve this problem. We know we have a mean of 0.031. Now what is the percentile? That's everything up to some value and less than it. So what we know here is that this area now, the area has to equal 0.2500. Now this is talking in diameters. We don't know what value this is exactly, but if we look at z-scores, we can actually find the z-score that corresponds to an area of 0.25, and the mean of z of 0 is 0. So what I have to do is I actually have to take my table and I have to scour my table and look for the closest z-score I could possibly find. So what I'm really looking for on the table is I'm looking at all those areas, those 4-digit numbers, the point blah 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 blah, and I'm looking for 0.2500. So I'm looking at the negative side of my z-table, and if I look where z is negative 0.77, I find a value of 0.2514. The next cell over at negative 0.78 is 0.2483. I can, as far as I'm concerned, I don't care which one of those values you use. It's going to be close no matter what. But what this means is this happens at where the z-score is. I'm going to choose 0.077. That this area is actually, well, it's actually a little bigger than 25%. But as I said, we're close enough. So I've actually done the hard work. I found my area, and now if I put this into my z-score equation, z was negative 0.77. X is the value I'm looking for. The mean was 0.031 and the standard deviation was 0.078. All I have to do here is solve for x. I'm going to pause the video and solve for x. And hopefully you pause the video and solve for x too. I got that x is 2.948. I'm going to go ahead and just round that to 2.95 centimeters. So if you like that problem, if you think you can handle that, try part I. What value of the diameters make up the 80th percentile? Go ahead and, what? Go ahead and pause it and give it a try. I'm just going to stop. Okay, so again, now we're looking for some value of x that makes up the 80th percentile. So we can already tell it's got to be greater than the mean, right? And this value has to be as close as we can to 0.80. And I'm putting that 3.01 there because that was the mean of my x scores, if you will. And now I'm looking for a z-score, where this is going to be 0.800, or as close as I can to it. So I'm scouring the table. I'm on the positive side since I know it's going to be greater than the mean. And I got a pretty good close number here, 0.7995, where z is going to be 0.84. So I got z is going to equal 0.84. And again, if you look at that z-score, if you weren't sure I got that, look at the value there. I got 0.7995. That's about as close to 80% as I'm going to get on the table. So once I do this, I just put this into my z-score equation. I'm solving for x. The mean was 0.031. The standard deviation was 0.08. And the value I get is, I'm working on it, 84 times 0.08, and I got a value of 3.0772, so that'll round to 3.08 centimeters. Thrilling, fun, yeah? You like these problems? Hate them? Can't stand them? Well, if you hate them, it's going to be a long year. So hopefully you love them. All right, guys, happy studying. Good luck on everything